Hello and welcome to Unwiring Tech. I'm your host Ranjana and today I'm here to talk about AI's engine, the data center boom and its impact on energy and environment. Behind the scenes of surge in infrastructure in AI, we often don't talk about its hidden companion, data centers. India's digital economy is growing fast and fueling the growth are massive data centers. Digital factories that run the world's most powerful AI models. But as we build more brains, we are also burning more watts. So the question is, can we grow smart without burning out? Let's start to understand it fully. Every Siri response, every Google search, every ChatGPT reply runs on hardware tucked away in a data center. Let's take a moment to zoom out and understand what data centers really are and how they actually work. They are industrial grade fortresses filled with high performance chips like GPUs to train and deploy AI models. You have probably heard the term a lot lately, especially in the context of AI, cloud computing, and digital infrastructure. But what are data centers really? Let's imagine a giant warehouse filled wall to wall with servers. These are high powered computers that store, process, and transmit almost everything we do online. Every time you stream a video, check your email, ask ChatGPT a question, that request travels to a server in a data center. Somewhere gets processed and comes back to you in milliseconds. Now, here is the part we don't usually see. Those servers get hot, actually really hot. Just like your laptop warms up after a few hours, imagine the heat generated by thousands of machines stacked together running full throttle 24/7. Multiply that by the scale of modern AI workloads, especially training large models, and you have got a serious thermal problem. And here is the catch. Too much heat can slow them down, damage components, or even cause shutdowns. That's why cooling systems are absolutely essentials in data centers. In fact, a big chunk of energy used in data centers does not even go into computing. It goes into keeping the machines cool enough to keep working. So when we say that data centers consume a lot of power, we are not just talking about electricity for running software, we are also talking about powering the cooling systems and backing it all up with generators, batteries, and redundancies to make sure nothing ever goes down. But like a candle burning at both ends, AI isn't it cheap. It demands power, a lot of it. By 2030, AI is expected to cause 165% increase in data center electricity usage globally. That's almost 945 terawatt hours, a number higher than what Japan consumes in a year. India, not one to be left behind, and is galloping fast. With an AI gold rush underway, cities like Mumbai and Chennai are witnessing a surge in data center investments. From coastal innovation parks to underground facilities, we are witnessing a digital construction boom. But what gets unnoticed amid this buzz of AI race is that every bit of that boom requires electricity. Chennai alone saw 340% increase in data center capacity between 2022 and 2024. Mumbai's growth almost doubled. Tech giants are planting roots across Hyderabad, Pune, Noida, and Bangalore. But we are now running into constraints of space, natural resources like water, energy, and infrastructure. To meet this demand, India is moving towards coastal regions, because coastal areas offer moderate climates, easier cooling options, and access to seawater and potential for offshore wind farms. It's a natural advantage. Even Microsoft's now experimenting with underwater data center. The recent report by International Energy Agency titled Energy and AI shared some important insights on the role of data centers in forcing governments across globe to redefine their energy infrastructure if they want to be part of AI race. According to the report, data centers accounted for around 1.5% of the world's electricity consumption in 2024. which is around 415 terawatt hours. The United States accounted for the largest share of global data center electricity consumption in 2024, which was around 45% of the total consumption, followed by China, who consumed 25% of it, and Europe 15%. Now globally, data center electricity consumption has grown by around 12% per year since 2017, more than 4 times faster than the rate of total electricity consumption. In fact, these data centers consume more electricity than factories such as aluminum smelters. Report acknowledges that yes, hardware and software are getting more efficient, but the scale of use is exploding even faster. For example, generating a few lines of text takes just a couple of watt hours, but a short video that can be 25 times more energy intensive. And we still don't know exactly how much energy most commercial AI models use, because quite frankly, that data isn't in public, according to the report, which makes policy making, energy planning, and environmental assessment really hard. Now let's talk about the hidden cost few talk about: water. Did you know a single mid-sized US data center uses as much water per day as 1 lakh households? Now transpose that to water-stressed Indian cities like Bangalore or Gurugram and you see the dilemma. Take for example the case of Pali, a small city in Rajasthan with a total population of about 230,000. It faces water crisis every year. So much so that city administration is forced to fetch water in special trains from the neighboring city of Jodhpur, barely 300 km away. However, there are few data centers in Jaipur where the daily water consumption supersedes the entire city of Pali. We are entering a world where the same infrastructure that delivers real-time healthcare in smarter cities could also strain our basic utilities like electricity and water. So it's a balancing act between progress and preservation. Now, it's not all that gloom and doom. India is innovating with both hands. Reliance is building a gigawatt scale green AI data center in Jamnagar, and companies like Princeton Digital and Yota are using liquid cooling and smart infrastructure to reduce environmental footprint. In Tier 2 cities like Kochi and Jaipur, edge data centers are popping up. Smaller hubs that reduce the need for long-distance data travel, lowering latency and power use. Smarter cooling, renewable power, nuclear options, even AI itself is being used to monitor and optimize energy consumption in real time. It's like training AI to fix its own diet. But here's the rub. AI is growing faster than our policies can adapt. We'll still face high costs for solar and wind installation. Grid infrastructure in many states is outdated. Regulatory delays are slowing green investments, and many data centers still run on old tech. In today's episode, we talked about data centers which are quietly but dramatically transforming our energy systems. And what does this mean for climate goals? Can AI itself help manage the growing demand it's creating? And how do we balance innovation with environmental responsibility? But the paradox is, AI could either strain our energy systems beyond their limits or help us make them smarter, cleaner, and more resilient. It all depends on the choices we make right now.